Solving modulus problems. F of x is 2 times the modulus of x plus 3. Take away 1. Sketch the graph of y equals f of x and state the range of the function. So let's draw this step by step so we can use transformations. So let's start with x plus 3. So the graph of x plus 3 has got a gradient of 1 and a y-intercept at 3. And then the modulus of x plus 3. Any negative outputs become positive. So the modulus of x plus 3, negative outputs become positive, so it bounces back off the x-axis. If we have 2 times the modulus of x plus 3, that doubles all the y values. So it's going to be steeper. The y-intercept was at 3. It's now going to be doubled. It's at 6. And then we need to shift it down 1 space. So shifted down 1. I'm going to shrink this and do it again. So shifted down 1, it's going to now intersect the y-axis at 5. And its minimum point was at negative 3, 0. It's down 1, it's going to be at negative 3, negative 1. So that is our function. State the range. So what can y be? It can be anything bigger or equal to negative 1. So f of x is greater or equal to negative 1. One for you to try. Pause the video, give it a go. So f of x is 3 times the modulus of x minus 1 plus 5. Again, we're going to sketch. So let's start with x minus 1. So our x minus 1 graph has got a gradient of 1 and a y-intercept of negative 1. The modulus of that is always positive, so it bounces back off the x-axis. So it's going to cross that at 1, not negative 1 now. 3 times that is going to be 3 times as steep. So it's now going to cross at 3. All the y values are multiplied by 3. And then plus 5, move it up 5. So our function it was at 1, 0. It's now going to be at 1, 5. And it did intersect at 3. It's now going to move up 5. So that's at 8 now. So it looks like this. And the range. So it can be anything bigger than or equal to 5. Another one, f of x is the modulus of 2x plus 1 minus 2. Sketch the graph and state the range again. So the graph of 2x plus 1 has got a y-intercept at 1 and a gradient of 2. So it's going to cross the x-axis at minus a half. The modulus of that is going to always have a positive output. So it's going to bounce back off the x-axis and down 2 spaces. So that graph moved down 2 spaces It did cross at 1 on the y-axis. It's now going to be at -1. And its bottom point was at -0.5, 0. It's now going to be at -0.5, down 2, so -2. And then we should also work out where it crosses the x-axis. So it crosses x when y equals 0. So what does y have to be? Y has to be 0. So our modulus is going to have to be worth 2. So it's going to be at 1/2. Going to be at 1/2. And it could also be -1.5. Because they both make a 2 for the modulus. So 2 halves plus 1 is 2. And 2 minus 1.5s is -3. Plus 1 is -2. But the modulus of that is 2. So that is our graph. The range, it can be anything bigger or equal to -2. Anything bigger or equal than -2. And solve f of x equals x plus 3. So f of x equals x plus 3. It's going to be shallower than this graph, so it's going to cross 2 times. So let's solve it. So our modulus graph is 2 graphs, one for each line, one for the positive line and one for the negative line. So we can have 2x plus 1 minus 2 equals x plus 3 for the positive line. And we can also have minus 1 times 2x plus 1 minus 2 equals x plus 3 for our negative version of the line, which is this one. So let's just solve. So we're going to take x away from both sides, add 1 to both sides, so x is 4. And then expand the bracket. So we've got minus 2x minus 3 equals x plus 3. So add 2x to both sides. Take away 3 from both sides. So x is -2. So x can be 4 or -2. One for you to try. Pause the video and give it a go. So we've got f of x is 3 mod x plus 2. Sketch the graph and state the range. So our mod x graph is that one. So it goes through 0, 0 with a gradient of 1. 3 times that is just 3 times as steep. And then if we add 2, it moves up 2 spaces. So it's going to be like this. Crossing the y-axis at 2. State the range. So f of x is greater than or equal to 2. Solve f of x equals 2x plus 5. So we've got a graph. It's going to intersect both lines. So we've got 2 possible answers here. We can have 3x plus 2 equals 2x plus 5. That's the positive version of the line. So take away 2x from both sides. Take away 2 from both sides. X is 3. Or we could have the negative version, which would be 3 times minus x minus 3x plus 2. That's the negative version of the line, equals 2x plus 5, plus 3x to both sides, take away 5, so x is minus 3/5.